We have looked at two methods of proof. The first one was direct proof and the second one was an indirect proof of type contraposition, and the third indirect proof type is called proof by contradiction. So proof by contradiction says that if you have a statement and you say that the negative of that statement cannot be true, then the original statement must be true. So this is the most simple form of proof by contradiction. This can be made more clear by an example which we will shortly do, but the basic underlying concept here is that you just need to prove the opposite of the statement, the theorem which is given, that it cannot be true, that you have to prove the opposite to be false. And that is done by reaching a contradiction starting from the opposite of the theorem. So if we are given with a statement P, you take its not P and you prove that this not P was false, and therefore P must be true. And from going from not P to false, we actually reach a point which we call Q. And Q is a statement that is the contradiction. So we remember that if not P, then Q is the definition of contradiction. In simple terms, again I'm going to repeat that we have a P. We just want to prove that not P is false using a contradiction which will be Q. We will see what that contradiction is. The example would be, for example, you are asked to prove that square root 2 is irrational. So the definition of a rational number is that we can express it as the fraction of two integers a and b. So where a and b both are integers, this is an integer and this is also an integer. If this is the case, then we are able to say that is a rational number. But we don't have a way for expressing irrational numbers except an inequality, an equal sign with the cross there, and that won't take us mathematically anywhere from that point. Let's say that all of this is P. What would be not P? Not P would be that square root 2 is rational, right? So now we are following the proof by contradiction, because direct proof wasn't taking us anywhere because the statement included irrational in it, and irrational cannot be translated into mathematical terms, but rational can be translated into an equation, and we can say that now not P can be written as that square root 2 can be expressed as a fraction a over b, where a and b are the smallest terms. They don't have any more factors that we can cancel out, meaning that, for example, a could be 3 and b could be 4, so there is no common factor, so that we can cancel them out and the fraction 3 over 4 becomes something else. A and b are lowest terms and b cannot be equal to 0. So this is another thing we need to mention. So now we can write it down as square root 2 of b into b equal to a. Then we can take the square on both sides and we can write down 2b square equal to a square, right? We can do that. And then what we can do, we can say, or we can see that this shows that if, for example, we consider this thing k, because b is an integer, b square will also be an integer. Let's call b square k, which is an integer. So what we can do is we can say that a square is even, right? If a square is even, a is also even. You can also prove this statement, but we're not going to prove it over here. So we have said that we have made one statement that a square is even, right? So if a square is even, a is even, this is our result from this part. But if I say that a is even, I can represent a as another number 2c, where c is another integer. Because a is even, I can express it as an integer multiple of 2. So I can write it 2b square is equal to, instead of a I am going to write 2c. So I get 2b square equal to 4c square, right? And dividing both sides with 2, I get b square equal to 2c square, which gives me another result that b square is also even, and which also tells me that b is even. So if I have two numbers, both of them are even numbers, and both are written down as a fraction. For example, if A is even and B is even, and I'm going to write, for example, I have 34 and I have 46, I'm pretty sure I can, divide this by 2 and this by 2. I'm going to land up with even, smaller fraction. So in other words, these are not the lowest terms, right? So if I say that A is an even number and B is an even number, it means that these are not the smaller terms written in a fraction, right? So that means my assumption was false. Therefore, A and B are not lowest terms. And what that leads us to? It leads us to the fact that the assumption that we made, that A and B are lowest terms, and we are expressing square root 2 as a fraction of lowest terms, this assumption was false. In other words, not P was false. So we have found out that not P is false. Why? Because of this contradiction. And this is the contradiction that proved that not P is false. And since not P is false, as not P is false, P must be true. And just to remind you of what not P was that square root 2 is rational, and P was square root 2 is irrational. So we say that this is proven. So this was the proof by contradiction for square root 2 being an irrational number. So square root 2 is an irrational number. We've just proven that, and I hope you understood. If you don't, you can contact me for any questions.